Hi everyone, good morning guys. Good morning. Welcome to the class. So let me wait for 2 more minutes. I want more participants to join and I will start the class. Just 2 more minutes. Okay guys, let me begin the class. While I open Jupyter Notebook. First, I want to check if there are any questions, any doubts. So far, whatever we have discussed about ANN and hyperparameters and deep learning, derivation, optimization functions, activation functions. Any questions, any doubts so far? Are you guys trying to also, after the class is over, are you guys doing some research on your own? You can read some blogs, you can read some books, okay? You can try to revise everything and write short notes, which I strongly recommend. I want everybody to write short notes, very like notes in like 1 page or 2 pages or whatever. If you do that, that will be fantastic. Which book? Any famous good deep learning book? I will recommend some books, okay, at the end of the class. Don't worry, I will recommend. Mm, okay. Okay, so let us implement a basic ANN model in Python using TensorFlow library, right? First, I would install the basic TensorFlow library. And then I will import it in my machine. Meanwhile, let me open TensorFlow documentation page or website. Right now, TensorFlow is having TensorFlow 2 as upgraded version. Second version is there. But so this is basically an end-to-end platform or framework available to implement machine learning projects. End-to-end as in from data reading to deployment. That is data, reading the data, pre-processing the data, and so on, all of the stages until deployment stage. This platform would give us that facility, give us that provision, right? There are many examples here given over here. I would also suggest everyone to open TensorFlow, this particular web page, and go through this completely. At least go through the tutorials on a rough manner, guide, introduction, and you need to understand what is this TensorFlow is, right? And as you can see here, the TensorFlow is available for multiple situations. That is for web. For web, usually we do it for web, and then we go to production, right? Normal TensorFlow in Python in our local machine, and then for web that is using JavaScript, right? We can do this, and also using on a mobile or edge platform, that is using Android, iOS, and these platforms. And for production, you can also deploy it using this TFX. That is, those are the hardware systems. Okay, so if you look at this is called as a tensor basically, right? This, you see, this is called as a tensor. So what is a tensor and why do we have something like this is important to know, right? So let us understand that. See, if you take 30 and you take 30 to 22, right? So what is this? This is a scalar, right? This is a scalar uh, number, right? And this is a vector, right? This is a vector. And I might have a matrix, which is a combination of, let's say, three vectors here. Okay, so I have a scalar, I have a vector, I have a matrix. Now, what is a tensor is, so observe this here, vector is made up of multiple scalar units, right? This is a single scalar, but a vector is made up of multiple scalar. When you put multiple scalar together in one place like this, you call it as a vector. And matrix is made up of multiple vectors, right? Matrix is made up of multiple vectors. Tensor, on the other hand, is made up of multiple matrices, just like in uh, just like a up level, right? You can consider. So initially you had only scalar, that is a single number, and then you had them together in a vector, and then vectors together you had in a matrix, and all the matrices together you would say it as a tensor. Fine, it's very important to know. So something I might have like this. Okay. So like this, if multiple matrices will be there, and that put together is called as a tensor. Why do we have tensor is because it is an optimal way to organize the data. It's an optimal data structure so that the calculations that are involved in the artificial neural network creation process, that is a deep learning creation process, there are multiple calculations that will happen, isn't it? Forward propagation, backward propagation, updating the weights, and calculating the loss. So many things will happen, and all of them will happen in a much optimal and fast manner when we have in this tensor structure, right? And things will get, when you have one more tensor also like this, the multiplication and everything will be much more quicker and faster, right? And you would also usually have a graphical structure representing the flow of the uh, calculations that need to be performed. Hence, it is called as a tensor flow, right? So here I have inputs, let's say, and here I have weights. So I would have a weight tensor and I would have an input tensor. Okay. Okay, I would have tensors here and here. So the flow is from here to here and here to here. So accordingly, how the calculation should be performed, a tensor graph would be created roughly, and the calculations would be created in that. It's called as a computational graph, right? We will call it as computational graph. We will see that also. But initially, right now, today, we are just going to see how to implement a basic artificial neural network model, or you can just say basic deep learning model, just using TensorFlow, we will implement. And we will not be creating any tensors, guys. We will not be creating any such tensors. Everything will be taken care internally, right? If you want to develop from scratch, then you may have to create these tensors. But if you're using existing methods available inside this TensorFlow library, which means, for example, for machine learning models, we used to use this sklearn, right? Scikit-learn, sklearn library. Inside that, there are multiple methods available. For example, linear regression class is there. If for that class, we used to create object, and then we used to call the fit method. Similarly, random forest dot fit method. So what happens is we are not creating any um, we are not creating any gradient descent algorithm, or we are not creating any Gini index. It's taken care internally, right? Everything is taken care internally when we just use the methods available inside sklearn library. Similarly, when we use the methods available inside TensorFlow, uh, for example, sequence, right, and everything. If we use these, then automatically a artificial neural network or deep learning model will be created, and internally all the performance and calculation will happen using this tensor. So you need not worry. But if you want to create from scratch, you need to definitely do that on your own. For example, in the previous class, we have seen how we have developed gradient descent algorithm from scratch. And of course, we have used for loop for that. And I wanted you to try to using vectors, vectorization. Try using vectorization. I have done it using for loop. And we all know that for loop is a slower process. Isn't it? For loop is a slower process. So we can do it using vectorization. You can see multi-folds of improvement. And please try that. So if you want to do everything from scratch, then you have to do everything implementation on your own. But that's not required, because we already have many existing libraries. We will see that one by one. Okay, and one more thing, guys. If you want to remember easily about tensors, just look at this. Doesn't it look like a Rubik's cube to you? Like a Rubik's cube, right? It looks like a Rubik's cube. And a Rubik's cube is made up of many cubes, right? It has many cubes. One, two, three, everything is, many cubes are there. And each cube, as you know, is a three-dimensional object. Three-dimensional object. It itself is like a matrix structure, actually. Right? It is like that. But it is like it's like multiple cubes joined together to make a Rubik's cube. Similarly, multiple matrices joined together to make a tensor. It's like a much more bigger level of data structure and high level uh, mm, structure, right? So that's how you can remember it. All right, now uh, go to tutorials. You can see here all of these. Okay, first let me import it. I'll continue here. I have installed this. Now import TensorFlow as TF. Okay, so I would have problem in my Jupyter file with TensorFlow, that is with respect to issue with respect to Mac. Let me open Colab. Yeah, and do you guys know which company created this TensorFlow library? Anyone?
No. Google.
Yes, Google. Google created this. Mm, it was developed by the Google Brain team in 2015. Their entire purpose was to make model building easy, fast, and productionizable. Very quick to do the go to the production and implement and deploy it in production. Okay.
How TensorFlow works?
It's in the same manner, how all the matrix calculations and everything will happen in the same manner, but things will run in much more parallel, right? So we have to look at the computation graph, then we would be able to understand a little bit about the flow, right? I will go into that probably in the further classes. At first, let us implement an ANN because we have already seen so far concepts about deep learning. So when we do something small practical, then it will be much more clear, and then we can look in the TensorFlow also, computation graph of how a graph would be created based on the model or what the task that we are trying to do. Okay, now let's import TensorFlow as TF. Yeah, okay. We have this. I also want to import other things, import pandas as this. I think now, yeah, we don't have to install everything directly. We can import in Google Colab. That is the facility we have now. And I also want to read the data. To read the data, I will use pandas. And to split the data into tests, train and test, I will again use model selection from sklearn. I will use sklearn. Sklearn dot model selection from this import train test split, right? It's called train underscore test underscore split. Yeah, it's the correct one. Okay, so I have these. Now let me read the data file. Okay, I need to import the data file. Okay, so I will take it as df is equal to read dot read underscore csv of okay. So let's see how the data is like. Okay, so I have churn data, that is, I have lots of details about customers, which state they belong to, account, area code, phone number. I have many details, and finally, they have an output feature called churn or not. So this customer has churned, and sorry, it has not churned. That's why it is false, and false, false, false. These customers have not churned, right? And these are the details of that customer. Okay, these are the details of the customer. So we can choose to take which particular columns are more appropriate. Let's see, df dot columns. So I have state, account length, area code, phone number. I don't think phone number is important. Day charge, day call, these are important. Voice mail message, voice mail plan. Yeah, these seem important. State also, maybe that is also important. Okay, but initially let me take only numerical values. Right here, I would be taking account length and voice, mail, message. These ones I will be taking. So let's take df underscore new is equal to df of I will take account length, area code, phone number is not required. because that will not impact the customer to churn or not to churn. And here definitely, as you can see, it is a classification task. We have to predict false or true, yes or no, right? Based on the some inputs. So I would be using sigmoid activation function in the deep learning model. Where will I use it? At the output layer. In the output layer, I will be using sigmoid because it's a binary classification. Otherwise, I can use softmax. We will see that also.
Tensor have a compatibility issue with
You need to put DF off, right,
Jupyter.
Manikant?
Yeah, sorry.
You need to put DF off, right, Manikant? Calls
DF?
is equal to DF is the name of the data frame, right?
Yeah.
How can you extract this columns?
DF,
Like, you
DF,
need to
yeah.
put DF off.
No, I'm not able to follow you. DF of?
Calls is equal to
Yeah.
DF of, you have to put there, right?
No. I am creating the names of columns which I want to consider. So I will take here COLS. That's it. That will be enough.
Oh, I see. Okay.
Yeah, because this is a uh, more refined way of writing the code.
Okay.
So let me take all this away and check.
Is it because it is inside two square brackets, Manikant?
Yeah. Are in columns. None of index are in columns. Yeah, I think let's take it this way itself. Okay, so we have this. I also have to take the target variable, which is churn. Right. So I have this. Okay. You recommended plots. Okay. Anyway, now after this is done,
Manikant, I have a doubt here.
okay, go ahead.
Why do you take the target variable as well here?
Sorry.
Why are we including the target variable here? It should be inside it should be inside another variable, right? The target variable. Only then we need to
No,
split
I
it.
am just taking all the data that I want. Here I have ignored few columns, phone number, which is not relevant.
Again, we are going to split this.
Yeah, into X and Y variables. X input,
Okay.
Y is output.
Yeah.
Okay, now let us do, I think for churn, I need to create false as 0 and true as 1. So let's do that. Okay. So I'll just take Y is equal to df underscore new of this churn question mark. That is the column name I have. And to this, I will do the lambda, right? And I will tell when I have false, make it 0. Okay. 1 if x is equal to, how do I have it? Sit in true or false? Okay. True. Else 0. If it is true, then make it 1, else 0. Okay, I will do this and let us see what will happen. Okay, it is changed. I also want to see y dot sum to know how many.
Is it because there is no full stop after true?
Full stop is there.
Yeah.
Okay. Okay. Let's see that way. Yeah. Okay, it's working now. Okay. Right. Thanks for that. So we have the data ready, guys. We have done all of the basic mm, basic stuff. We can do more, but let me just go into creating X and Y so that we can immediately implement the model. Okay, so X would be tf dot underscore new dot drop off
Axis equal to 1.
like that. Yeah, okay. So we have X and Y. Now we will divide that into train and test. Pass X and Y. And I can give test size as 20%, 0.2. Okay. Okay, small x. Yeah, so train test split is done. Okay, now I would from TensorFlow. So we already have installed TensorFlow. Now I want to call some methods from TensorFlow. TensorFlow dot keras dot models. In this, I will import sequential, which we will use a lot of time from now onwards, and load underscore model. Okay, sequential is to create a layer 1, layer 2, layer 3, like input layer, hidden layer 1, hidden layer 2, hidden layer 3, and output layer. In a sequence, we have to create. For that, we will use this sequential method.
What is
And
Keras?
Keras is actually another library built on top of TensorFlow. Right. For example, pandas, if you take pandas is built on top of NumPy, right? NumPy has basic vectors and vector manipulation, vector multiplications, dot product, and all of those. And from that, pandas was built where pandas could deal with data frames. And each data frame has multiple columns. Each column is nothing but in a way vector. Right. So similarly, TensorFlow, from TensorFlow, Keras is built. And usually we will be using this one. Inside this, there are multiple methods available, which we will use to create the deep learning model. Right?
Okay.
We
And
will.
why we went for X and Y format kind of thing? What's the benefit we are getting there?
What's the benefit? As in, how else will we go?
No, means can you go up
Yeah. Yes.
that X thing? Yeah.
Mm-hmm.
Okay.
What's your
Fine,
question?
fine. Okay, Chan, you drop. Okay.
Yes. And I will also import dense layer. Okay. And we will have a basic evaluation metric called accuracy from metrics. Accuracy score is there, which we can directly use it. Okay. So dense is nothing but that all of the connections will be possible. Right. We will have to use this. We will see one by one when I write the code. So now let me comment this. BUIL build the DL model. Okay. First, I will create a name for the model. Let's say DL underscore model 1. For this, creating an object for sequential. Sequential is a class. Okay. And for that, I'm creating an object like this. Now, in this, I have add method. Okay. I have add method. So what should I start adding? I should start adding layers, hidden layer 1, hidden layer 2. And also I should add neurons inside each of the layer, right? That is exactly what we will write. And I want to add a dense layer. So again, while we actually write code one by one, always try to visualize the deep learning model. Okay, so initially one input layer, okay, and then hidden layer 1, hidden layer 2, let us say one final output layer. Okay, so what is the meaning of dense? Let us try to understand. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. And similarly, I have here. So here, all of the connections are there. All of the possible connections are there, which is 4 into 3. Right? All of the possible connections are there. Here, how many neurons are there? 3. Here, how many neurons are there? 2. So the possible connections are 3 into 2, 6. But sometimes I may not have all of the connections. I will have only this, like this. Right? So only 4 connections are there, which means this is not a dense layer. It is not dense. It is, you can call it as not dense. If it is having very few connections, then you will call it as sparse. Okay, so obviously when we build a neural network model, I want as many connections as possible so that the complexity increases. The information flows from this to this to this to this. All of the possible information flows. So usually we will build dense only, right? Sometimes later on we may decide to drop some connections. For example, here, this here to here, here to here, here to here, and here to here. Let's say all connections are there. Later on, I decided to drop this, right? Drop this and then drop this. Instead of 6, I am ending up with only 4 connections later on. That is called as dropout mechanism, and that is to reduce the overfitting issue. Right? Every model can be prone to overfit. Deep learning model is also prone to overfit. When it is overfit, obviously you will reduce the complexity of the model to reduce the overfitting issue. Right? How will the complexity be reduced? When the connections are reduced, right? And when the activation function is removed, right? And when the layers are removed, when the neurons are removed, whatever it is, multiple ways are there. One way is you remove the connections. So instead of having dense connections, you will have non-dense connections. Not all connections will be there in between the layers. That is something called as dropout. Okay. But here, as I am proceeding and creating a neural network architecture, visualize everything. Okay. And how many particular input do I have? Let us check how many variables I input variables I have. Guys, X. Okay, I don't have capital X. I think it's small x. Dot shape. 16 columns are there, right? In X train. So 16 input variables. are there. So I will add a dense layer. I want to add a dense layer. Okay, dense, in the dense method, I want to add units. See, when I say dense, which means one dense layer has been added like this, let's say. One dense layer has been added. In that, let me add 32, okay, or 64. 64 I will add. 64 neurons. That is units equal to 64. I have this.
Money not getting on, not getting, it is getting too high.
What do you mean by too
This
high?
DL model, sequential, then DL model, add dense unit.
Just wait, just listen, let me finish. You will understand. Okay, I will repeat that again. Let me finish. So 64, and then I will also add activation. I can add ReLU. Okay. And always for the first particular add method that I will use, it's always that I will be adding hidden layers, right? Always adding hidden layers, because input layer is in a way already defined and decided, isn't it? Because we know what X is, X train is. So we know the features to consider in X. So that is already fixed. What we need to create and add is the hidden layers. Output layer is also fixed. We know we should have only one neuron in the output, right? So in a way that is also fixed. So we will add that also, but this is the way to create a basic ANN with, I'm adding a dense layer, that is a layer where units, that is number of neurons, are 64. And in that layer, the activation function I'm considering is ReLU, right? And for that layer, I am adding an input dimension, right? This is always only for the first step. So let me take it as 20. How much was it? Okay, I can also do len of x underscore train dot columns. Okay, this also I can do. Okay, all right. Now I can add further model one dot. I will add one more. I want to add one more dense layer, right? Dense layer. So what has happened so far? I
So
have
one hidden layer H1 is added, is that right?
Yes, that's correct. And
Okay.
and the input I have defined.
Yeah, got it.
Input dimension. Input dimension, I'm telling number of neurons to be considered in the input layer, which is equivalent to number of columns in that my X-ray. That's what I have defined.
Sir, is
Okay.
it like yesterday you told like something 2 power n or something?
Yes, that is for the hidden layers. 64 I have taken.
Okay.
Right. For the input, it is fixed, right? Because how many other features we are given? We may be given with 3 features or 40 features, that we have to take it in the input layer. There is no other this thing, no other way.
That I understood completely.
Yes. One.
No, you have 16 column and you have 64 neurons. That's what you are saying, right? How they are going to be there? It's unit 64. So how that thing is happening?
No, see, understand this. So here I added a dense layer. So visualize the network also. I added a dense layer. Okay. And in that dense layer, I am adding 64 units, which means there are 64 neurons. 64 neurons, which is nothing but 2 power 6. Okay. Like I told, in terms of 2 power n, we have to have. And then activation function is ReLU. Here, ReLU will be there for every neuron. Okay. And then input dimension is equal to length of this. Let us say there are around 20 features, 20 input features. I'm adding an input dimension layer. So now one more layer will be added, which is having neurons equal to the number of columns. If 20 are there, then 20 neurons will be here, right? That's it. Because I told dense, all connections will be there.
Okay, that's what this line means. Okay.
Yeah, that's what. If I finish everything, then I can explain one by one. Okay, I will explain everything 2-3 times, guys. Don't worry. I will draw the diagram also so that you can connect. Okay. So first observe this sequential I told. Sequential means what? Whatever layers I will add, one by one it will go. So I'm adding one layer here. One layer I've added, which is dense layer, consisting of 64 neurons and ReLU activation function. Also, in the first addition, I will always have to include input layer. This is the way we have to write the code, because TensorFlow people have developed the methods in such a way that this is how we have to write the code. So we have added this. And since I said dense, everything will be connected. Now later I can add one more hidden layer also. Why should I restrict to only one hidden layer? I can add one more hidden layer. So I will write the code again. Model. Right now the model is having this. Right now DL underscore model 1 is this much. To that I am adding one more dense layer. Okay. But in that layer, how many units I want? I may want to have 32. So I will mention that. Right. And activation function, I can take anything I want. I will mention that. Right. That's it. So since I told dense, all the connections will be there. Like this. So this is what is the structure of ANN till now. So let me write that part of code also. I will just erase all these and I will draw everything again, guys, because it may be too confusing. So, okay. So right now I will just let me do it from beginning. Model 1 dot, I want to add one more dense layer. I will add with the units neurons. I will consider 32. Okay. And I want to have activation function also. Just have to say activation equal to ReLU. Okay. That's it. This one be there. That's it. Right. Now you can see with this lines of code, how will the ANN or DL model will look like. First of all, it's a sequential model. So layers will be added one by one. So initially I added an dense layer with 64 neurons. Okay. And ReLU. So ReLU activation function, and input is this much. Input layer is this much. 20 neurons, let's say. Okay. Like this, it will be there. And then I'm adding one more dense layer. So it will not go over here. The new dense layer will not be somewhere over here. Like this, that will not happen. It will go in a sequential manner. Right. So the next layer added will be here in a sequence. And that is having 32 neurons. Okay. And ReLU for every neuron. And since I told dense, it will be like this connections, all possible connections. That is 64 into 32. Here 20 into 64. These many connections have happened so far. These many connections or happened so far, which means these many weights will be there, right? Because W1, W2, W3, and then W200, 201, whatever it is, like it will have those many connections. Okay, so let us stick to only two hidden layers. Finally, I want to have an output layer. So what should I do? I should ideally write dot add, and then I will write dense, because I want all the neurons in the previous layer to be connected to my output layer, right? So I'll write dense, and what I will write, units will be how many?
1.
Yes, 1. And activation function will be what?
Sigmoid.
Here it
Yes,
is.
exactly. That's it. That's the only change. So now let me write that line of code. Same model, this model, whatever has been created, add dense, because I obviously want all of the neurons in the previous layer to be connected to my this layer, which is my output layer, equal to 1, and activation is equal to sigmoid. Okay. I will also put this hash here. Let me also write this: creating hidden layer 1 and input layer. That's happening in the first particular line. In second line, I'm creating hidden layer 2. Finally, creating output layer. That's it. Here I can tell that I'm creating a sequential adding layers. Okay, that's it. Fine. Now let me run this. Dense add. Okay. Just small minor syntax mistakes, guys. Okay, we created this. Okay, so is my deep learning model ready?
Yeah.
It can predict. Can it
Yes.
predict?
Only when, yeah, it is
Yeah,
correct.
it
Yeah,
can,
it
it can. It will.
So if I do DL underscore
It has to
model,
put to the data.
yeah,
Yeah,
we have not trained it. We just created architecture, right? I wanted to have two hidden layers with 64 neurons here, 32 neurons here, and an output layer and an input layer. This is what I had in my mind. And I wrote the code for it and I created it. But the weights are not yet computed, right? W0, W1, W2. It's not computed. It's not trained on my data, X underscore train. I have to do the
Yeah.
training,
Hmm.
right? I just created architecture here. Right, there was nothing to create for linear regression. It's we just used to take W0, W1, X1, W2, X2 like that. We used to take. We just have to define what is the input, what is the output, and then LR dot fit. Model building is done, right? But here we need to create the architecture, right? We have to define the architecture. We can change the architecture also, right? In future, like after we get the prediction, we are not satisfied with the prediction, we can change the architecture and then again rebuild the model. Right now, we just created this basic architecture. Now let us build the model, right? So I will write here, creating the DL model. Okay, next we will simply build it. Okay, so the way we have to do is, we have to do give the model name, right? Model one dot, and we know that this is an object, right? That we have created, and object has a lot of methods. In that, one method is there is compile. When we run this compile method and give my train data, right? Sorry, compile method is to define my other hyperparameters, such as what is my loss function, right? And what is my optimization algorithm I want to use? What is the metric I want to use to evaluate? So since it is binary classification, it is binary cross entropy. Binary cross entropy, the loss function will be. And after loss function, we have it is optimizer. Yeah, optimizer. And I will just give stochastic gradient descent, guys, for now. Okay.
Binary
Great.
cross entropy. Loss
Binary. Oh yeah, binary.
Yes.
Okay, thanks. Binary cross entropy. Okay. And matrix accuracy, I can use matrix. Okay, so let's run this.
what is this accuracy?
Stochastic gradient descent. Accuracy, it is the if we want to see what the performance of the final model, I want to use the accuracy to see it. It's on the train data. So model will use this as the loss, right? And it will use this as optimization function to reduce the loss. After model is built,
Summerly.
after the model is built,
Yes.
it will predict on the train data and show me what is the accuracy. That's why I have this. Yeah, is that clear? Okay, all right. Now let us proceed. Now model 1 dot fit, same fit. I will fit it on X train, comma Y train, right? And here we need to give epochs, if you guys remember, right? I'll give 20 and batch size. I can give batches. If I give batches, then it will run as per the batch. Batch size I will give 16. Okay, I'll give more because I want it to run sooner. Okay, so let's run this. Okay, let's remove this and check. Yeah, it's running. So initial accuracy is this, and then it's increasing. Loss you can see here. Initial loss is this, 17. Accuracy is this much. Later on, loss reduced and accuracy has improved. Across 20 epochs, like this. So final accuracy is this much. So we built a model on trained data, right? You can change the number of epochs to 50, for example, and we can try it. And let's go to TensorFlow. You can see here. Optimizer Adam. I want to know the mini batch stochastic gradient descent. What is it called so that I can try it? Probability TensorFlow graphics. Yeah, this will be useful for later. Optimizers. Yes. Yeah, SDG with momentum. RMS prop. Okay, batch I have taken. And I can try with Adam. Since we have not learned Adam, let me not implement that. Okay. Yeah, so here 50 epochs. Accuracy is almost same, 87, 87, 87 everywhere. So yeah, that's it. Okay, so now let us predict on the test data and train data also.
Are you using only CPU or did you attach any
No, it's just
CPU?
CPU because it's very small data, very basic Excel data. So it's just CPU. Y underscore hat is equal to DL underscore model 1. Right now the model is built. Right now model is built. I want to predict it on train and test.
So while compiling the model, is that a particular order like optimizer, loss, and thing we have to give?
No. You can give anyway. Those are just parameters, right? You can give it anyway. No, order is not important.
Okay.
Predict. So if you see here, the predictions will be in terms of zeros and one in terms of numerical values, and we have to give the cutoff. You see here predictions are like this, right? But we want predictions which are either 0 or 1. That is, he will churn or not churn, right? So we can give cutoff. Anything greater than 0.7, 0.8, it is like he will churn, otherwise not churn. So let me do that. If, okay, I'll take it y train hat is equal to 0 if val is less than 0.7, let's say, else it will be 1 for every val in y underscore train underscore hat. Simple. Okay. And then I will check train underscore hat. Yeah, it's all like this. Similarly, I will do it for test as well. This would be test. Okay, it's done. Great. We can compare the accuracy.
Margaret, can you go to little above the
Yeah,
place where we put the model, right?
where we build the model.
Yeah, not
Yeah.
building, I think, where you train the model. Can you go to the-
Okay, sure. Just a minute. Y underscore test underscore. I just want to see what is the accuracy we got. 90% and '87 on train, 90 on test. So it is good, not overfit. It is good. Yes. Now this is where we have trained the model. Yes. Model creation, that is architecture creation is here. Building the model or training the model happened here. So what is your question in this?
Okay. No, I just thought like we are also calculating the training accuracy. So
No. Yes, we are. Here we are getting the accuracy printed for every epoch.
Mhm.
50 epochs, every epoch. It is not required. It is not mandatory. You can just remove it and do it because anyway, I can see the loss. I gave the loss as binary cross entropy. So I can see the loss and judge how the model is getting improved in every batch. In every epoch. But loss, see, loss 0.35 means is it big or small? I don't know. Right. Accuracy is always between 0 to 100. So I can tell 70 is not great, 90 is good, like that I can tell. Loss I can never tell. Is 0.3 high loss? Is 30 high loss? Is 70 high loss or low loss? I don't know whether to tell. It depends upon data and I may not be having any information about it. So, so I'll have something else called as other metric just for me to understand how the performance is going on. But this is not taken as a criteria to update the weights. Only this is taken as criteria to update the weights using stochastic gradient descent. That is, gradient descent with momentum in mini batch because I'm taking batch 6. So I've done a mini batch stochastic, mini batch gradient descent here. Matrix is, just a second.
Accuracy spelling is incorrect.
Yeah, okay. Got it. So this
So
will
we
run.
didn't run the fit model against test data, right? Whether it's needed to run
Why on test data
validation
we will
data.
run?
We don't need to validate that test data.
Fit, what is the purpose of fit?
I mean,
It is used to actually train the model.
the model.
Yes, we will train the model on train
Model.
data. And then when the model is trained on train data, we want to test how is it on the test data, right? Where it should not be trained. What is the purpose of having train and test?
The training for training the model and test is used to test that trained model.
Yeah, so why can't we take entire data and then train the model on the entire data? Why to waste this one?
To
Because
have
we will not.
some unseen data.
Yes. And why do we have to have like that?
Because we'll not get to know whether the model which we have built is
Hmm.
performing well or not on the unseen data.
Yes, correct.
Manikant,
So
I have a doubt.
yeah, sure. Let me just finish this point and you can ask your doubt. So see, we divide the data in train and test. What we build a model on the data set. Usually this is the process, right? We will show the data to a model. Okay. Model will learn something and it will predict the future. It will predict the future, right? As much accurately as possible. But let us say after 6 months, after predicting the entire future for 6 months, we realize model was not good. So what happened? All the 6 months is gone. Time is gone. Cost is gone. Everything is gone. So we should not be waiting for the future events to happen and then compare it with the prediction. Right, 6 months we should be waiting. Future events today, from today, 6 months later, that is the future events has happened after 6 months. After 6 months, if I check the performance of the model and I realize it is bad, then I will rebuild again. Then what is the whole point? So we should never wait for the future, right? That's not the way. You have to decide immediately, right? So we will divide the data into train and test. Train and test. Where test data we will not show to the model. Only train data we will show to the model, right? So for train data acts as the past data to the model, right? And test data acts as future. But is it the future? No, it is not. It has already occurred. Test data is nothing but past data only, right? We know it. For humans, it is past data, but for model, it is not. For model, it is as good as future data only because it has not seen it, right? So let us say from 2000 to 2020, we have the data. But I am showing model only 2000 to 2016 data, right? Model has looked at only this data and it has learned the pattern. And 17, 18, 19, 20, it is predicting, right? Which means for the model, it is like future only it is predicting, right? Because for the model, this is past. And based on this past, it is predicting for 2016, 17, 18, 19, 20. But I already have that information, which I have saved it. I have not shown it. I have not shown to the model so that it will act as a future data and I can compare and see the performance on the test data of the model. I have the actual test data, right? I will have the model prediction of the test data. So I can compare the performance of the model in the future without waiting for the future, just by hiding some of the data from the past. Right? That is the idea. So if I have the data, I split it and I build a model on both, then the purpose is not fulfilled. We build it only on this and we test on this, also we test on this. We test if in the future it will work well. Yes, it's working well, but sometimes after a few months it will not work well also. That can also happen. That could be because model drift or data drift, pattern is getting changed or other factors are coming in. That will happen. So continuous monitoring of the model will should be done. That will come into ML ops and everything. Okay. Yeah, fine. So you had a question. Please go ahead.
Yeah. So in this deep learning, actually, pre-processing is not required. Is
No,
that
no, it
so?
is required. It is required.
Even though
We have to.
the features are in different scales, we are getting good accuracy.
Yeah. That will. That is the advantage with deep learning models.
Okay.
But still, we will do the feature scaling and normalization.
Okay.
Batch normalization, we do that. We will be seeing that in the next classes. It is good to do. So we do it.
Okay. Yeah. Okay.
Niket, I have a question here.
Hmm.
See, here we are specifying the batch size, right? When you put the model,
Yes.
and we are giving the number of epochs to be performed. Now,
Yes.
like
Yes.
for the batch size, it would be doing the random sampling without replacement, right? For each iteration. I mean, iteration as
Yeah.
in
Yeah.
without replacement. Okay.
Huh.
So, I mean, maybe whoever is building the model, he might
Hmm.
not be knowing in how many epochs the accuracy would be like saturating, right? Like
Yes.
in this case, it
Yes.
is almost 0.87 like this, right? For some like that.
Yes. Yes.
Now, I mean, is there a way we can control the model to say that after the point where the accuracy is not improving,
Hmm.
we'll have to stop rather than
Continuing.
continuing for all the epochs that we mentioned. Is there
Yeah,
a way?
yeah. Yeah, it is they are there. It is there, but we just have to write some extra bit of code. But usually what people will do is they will not do such things because there could be a scope of let's say in epoch 18, 19, 20, 21, 22, it got saturated, and suddenly from epoch number 26, 27, 28, it suddenly loss decreased a lot. It could happen, right? Because as we have discussed, the random jump can happen in mini batch or stochastic gradient descent. That could happen. So people will allow for that possibility, right? And
Okay,
they will
then
run for all
how do we
epochs.
decide then the number of epochs?
That is a hyperparameter we have to tune. It cannot
Okay.
be estimated accurately. People will try grid search, random search with multiple things like 20, 30, 50.
I mean, ultimately, there would be a watch on the accuracy of it. I mean,
Yeah,
so-
exactly. Yes, yes, yes.
and-
So right now we just built a basic deep learning model, guys. We have not done any hyperparameter tuning at all. What are the hyperparameters we can tune? I can change the optimizer. I can change loss function. I can change number of hidden layers. I can change neurons in the hidden layers. I can change dense to sparse. Right? Why dense connection? I can sparse. Yeah, I can drop out some connections. Here I will. You can later tomorrow you will see that I will add a dropout layer, right? Which means it will drop randomly 20% of the connections between two layers. Hidden layer one, hidden layer two. Let us say there are 64 cross 32 connections, and that is because of this particular code line. And now later I will add one more code line called dropout. I will ask to drop 20% randomly. So 60 multiplied by 20% 0.2, those many connections will be dropped randomly. Right. This is to reduce the overfitting issue. Okay. Yeah, this is to reduce the overfitting issue. So like that, many hyperparameter tuning we can do, but one more deep learning model we can build, and then we can try for other kind of hyperparameters and all. So let's try to build one more deep learning model, guys. Just a second.
Can we just scroll down, please?
Let's scroll down. Okay. Yeah.
Not that much. Yeah, this much.
Yeah. Here.
Okay, this is 0.7. Okay, but can you just scroll down, please? No, final accuracy, what it was showing. I just want to check that part.
Final accuracy. If final accuracy on train is this, on test is this. You can still improve it. You can add more hidden layers and see. Let us try that. We can improve this further. Okay, now model building. Oh, okay, it decreased now, 85, 86, it got decreased. So we have to do, it's leading to overfitting. So we have to do dropout and everything. We can see that later, right? I can reduce this to 16 maybe and see how it functions. Yeah, it's still the same.
It's lesser.
Yeah, it's lesser. So previous one was better. So like I said, it's all hyperparameters which you have to play and test. Okay. Yeah. So actually next I want to work on some images data. So let me continue that tomorrow. Okay, because that would take some time to describe the data and also to create the model. Fine. So, okay. So I just want to see if any other questions, any doubts are there. Is this clear, everyone? At least the basic neural network architecture creation should be clear.
Yeah, it is
And
clear.
then, yeah, once you create the architecture, you can compile and decide other hyperparameters like the loss function, optimizers. And if you want to see what are the optimizers available, you can go to this particular official page. You can see here TensorFlow module optimizers. You can see I have ADA, Grad, Adam, AdaMax. Many are there. We don't have to learn everything. The most important are gradient descent with momentum, stochastic gradient descent, mini batch, Adam, RMS prop, right? So these are ADA grad also is important. RMS prop, these are important. And there are variations which you can keep learning further as you proceed further. And you can also see about regularization techniques like overfitting, elimination techniques, L1, L2, we have these, right? So you can always come to the official documentation and check what are possible. Loss function also you can see. So just see TensorFlow, loss functions. You can search for regression task, also for classification task. So you see you have many loss functions. Binary cross entropy is one. That's what we have done. Hinge loss, Huber, variety of loss functions are there. And everything is important based on the type of data we are dealing with and use case we are dealing with. Poisson loss function, MAE loss function, root mean square error. Mean square error is usually we will use, right? For regression, mean square error.
Yeah.
We can also use mean absolute percentage error. Then things will change a lot, right? And KL divergence, many are there. Cosine similarities, like this is not mostly used for real world situations. It's very rare. Many are very rare. Mostly used are this one. Poisson sometimes I've seen we are using. MSC, like this we'll be using. Okay, KL divergence is also important. Hinge is also very important. It's easy. It's easy. Don't worry. We will see that. Okay. And if you want to know about other things, you can. I would suggest please go through this page, guys. TensorFlow. Just open TensorFlow and then have a quick glance. You can do it in your mobile, no problem. Just get familiar with this particular TensorFlow library. What are all the options available? Right. You just have to get familiar. And you can read all of these. You can see some tutorials, anything, whatever it is, keep learning continuously. Okay.
Can you
All right.
please upload it to the drive, the one which we did today?
Yeah, sure. I will
Also the
upload it.
data set, Manikan.
Yeah, okay, sure. I'll upload it. Okay, let me stop sharing my screen. Okay, any questions, any doubts? How are you feeling? Is it easy? Is it hard? Okay, books. Yeah, thanks for reminding. I wrote list of books. Let me check. But I would not suggest everything.
Can we use this random search or grid search CV here in deep learning?
Yes. Definitely. We will be using that. Yes.
Okay. And I have one generic doubt, like in this random or grid search, we will use one parameter called CV.
Cross validation. Yeah.
Yes. Means what we are taught is it will partition the given data into to make into equal partitions. Like if we give five partitions will be done, and 4 will be used for training, and 1 will be used for testing. So we will pass the training data to it, or the whole data set will pass?
The whole data set. The whole data set will be passed, and one part, let's say, whole data set can be divided into 5 parts. If there are 100 records, you can divide into 5 parts, so 20 in each part, right? So now what happens is the first 4 parts will be taken as train, last part will be taken as test. But this is not the only way. You could also have taken last 4 parts as train and the first part as test. That is also one way. Like that, 5 ways are possible, because in test only one part I will be taking, right? And I know 5 parts are there totally. So 5 ways are possible. So for every possible way, model built will happen on train, and prediction will happen on train and test. So here 5 possibilities are there. So 5 models will be built, and you will get predictions on train and test for each of the 5 models. And finally, average of all of that will be taken as the final, accuracy, whatever it is you choose, as the train and test. The reason we are doing this is because I don't want model to be sort of like memorizing the test data also, and then predicting it well, but not predicting it good on the other part. So that should not happen. That's why we'll do this.
Okay. If we pass any binary classification data to it, will it ensure, like during partitioning, like equal same proportion of
No, it will not ensure. It will not ensure. So usually what happens is the records will be put in part 1, part 2, part 3 randomly. It will be put in randomly. Right. If you want to ensure class balance, everything will taken care, you can do stratified sampling. So since I am saying randomly, it's nothing but sampling randomly, right? Random sampling. If you do stratified sampling, that will make sure that the class distribution for all of the part 1, part 2, part 3, part 5 is almost same. Almost same. So it's just a parameter you have to choose. In that grid search, you can see CV you can give, and stratified sampling you can give, and it will take care.
Okay, that is also one of the parameter, right? Stratified
Yes.
something.
Yes.
Yeah. Remember. Thank you.
Okay, so I will be typing the name of the book, guys. Just please try to search, find this. Let me know if you're able to find tomorrow. You let me know. Yeah.
So that CV, what was the full thing CV we just talked? Sorry?
CV?
Okay.
Yeah, what's your question? TensorFlow by okay, just try this book. Okay, this is Keras, not Kerbs. CERAS, Keras. Keras TensorFlow. Hands-on ML with Keras TensorFlow by Orleon Guéron, as you can see. Just try to see if you can find this book. I have typed the name of the book in chat box. Okay, any other questions? Any doubts so far?
Manika, did you put that in? Okay, good.
Yeah, chat box, yeah.
Manikant?
Yeah.
So, I guess Kiran asked, right? If the data set is imbalance, we don't have to specifically go for smooth kind of thing. Instead of that, we can directly use the stratified. Is that what you meant? I just lost somewhere when you were saying that.
Yeah. That will make sure the data classification, the class distribution will be same in all the, No, it will not be balanced.
Okay.
So smooth is to improve the imbalance, that is improve the balance. So for example, if you have 95 class 0, 5% class 1, we do smooth so that we synthetically create more data for the minority class, that is class 1, in this case 5%, and then we try to bring it to same balance, that is 55, 45, whatever it is, right? That is for this one, which is good. That is one technique. But we might not need it. Sometimes the class distribution can be 65, 35. This is okay. We don't need to do smooth. It
Okay.
might not require.
Hmm.
But what Kiran was trying to give a situation is when the entire data is divided into 5 parts. In part 1, it can be 65, 35. Part 2, it can be 90, 10. Part 3, it
Okay.
can be, let's say, 45, let's say 35, 65. Like that, the class distribution is changing for every part. On the
Okay.
entire data, it is 65, 35, right? In every
Hmm.
part also, it should be same. Otherwise, the learning will be not correctly done.
Yeah, got
Right?
it.
Because you're doing in every part, the records are put randomly. It's a random sampling.
Yeah, got it.
If you do stratified sampling, it will ensure the 65-35 ratio will be maintained in all 5 parts. Not exactly like 63, 37, 64, 36, 70, 30. Like that, it will be there approximately in all of the parts. That you can do stratified sampling, not to tackle the imbalance
Yeah,
aspect.
got it. Thanks.
Okay, all right. So guys, tomorrow we will build one more deep learning model, right, on images data. We will be doing multi-class prediction, right? That is, instead of binary class 1 or 0, yes or no, we will do multi-class. Digits will be there 1 to 10. Okay, and then we will do hyperparameter tuning, right? And then we will also see the output, how the output will be like in the prediction. Very simple, very easy. It will take around 30 minutes, 40 minutes to just to finish the code. It'll be very easy to understand. Okay, nothing to worry. And I will ask one question now. I think many of you can tell now itself. If it is a multi-class prediction in the output layer, how many neurons should I have and what activation function should I have?
Activation function should be smooth. Softmax.
Yes,
Yeah.
yes, exactly. And only one neuron should be there because that will tell which class it will belong to, or it will just give the number. So that should be enough. Okay. Yeah, that's it. That's correct. Everything else is almost same, but hyperparameter tuning we will see tomorrow. And also some theoretical concepts we will see tomorrow. Okay. Fine. All right, guys. That's all for today. Thanks, everyone. Bye, guys. See you tomorrow.